Okay, Assalamualaikum warahmatullahi wabarakatuh. So we meet again. Uh, so for this lesson is more towards on to derive the output voltage ripple equations. Okay, so as mentioned for the buck converter, actually the output voltage ripple, which is we denote as a delta V out, is one of the most important parameters in designing the DC-DC converters, and this is the ripple voltage is actually related to the capacitor value that we choose. Okay, so in this lesson, so we will derive the equation for the ripple voltage and its relationship with the capacitor. So actually, we will start with the current capacitor here. So the current capacitor, the KCL, from this circuit is actually we have the I diode, which is time dependent, is equal to IC plus I out. Okay, and we know that I out is a constant DC current, which can be calculated as a V out over R, or we can say because this is constant current, so we can just put I is equal to V out over R. Okay, so right now we have already know about ID is equal to ICT plus V out over R. Okay, so our main function is right now IC. So IC we rewrite again, so it's actually equal to I diode minus V out R. So V out over R is a constant. Okay, it's a constant current. So right now we don't know ID. What is ID here? What is the I diode waveform looks like? So based on the circuit here, we can see that this I diode is actually equals to the current of the inductor, but not for all conditions. Okay, so if you recall, when the switch is on, the diode is off, and when the switch is, so meaning that there is no diode, there is no current that flow into the diode during switch on. But when the switch is off, we can see that the current inductor will flow through the diode. So we can say that the relationship between I inductor, the current inductor, and the current diode is that I diode is equal to only for during the switch off, which is 1 minus D IL T. Okay, so meaning that the diode waveform is like this. During turn on, it is off. Okay, this is during switch on. But during the switch off, the diode will have the same current of the inductor. So I just recall the inductor current is like this, right? So this is ILT. So this is your switch on. Okay, the diode current may be like this. The inductor, okay, the inductor current. So it will follow. So this is on, this is off. So I diode is equal to the I inductor during switch on only. So that's why we have only current here, which is equal to the current of the inductor during switch off. Okay, so I diode. So this is the waveform of the I diode. Okay, so since then we have the I diode, then we can actually draw the I capacitor. So can you sketch the I capacitor for me? Or Okay, so actually the I capacitor, if we can see here, is I diode minus V out of R. So we have already the I diode here. Okay, so minus a constant current. Okay, minus a constant current, which is I out. The value is V out over R. So by using this sketch waveform, we have already got my I capacitor. My I capacitor will actually shift it down. The value of the shift is actually V out over R. Okay. Like this. So this is my I capacitor. Okay. Okay, so we so I erase this waveform. Okay, so we continue. So we already know that the charge of this inside the capacitor is equal to the capacitance value multiplied with the voltage across the capacitor. And we have already know here that the voltage across this capacitor is equal to the output voltage. Okay, so any change in the charge is actually due to the change of the V out. So we make our V out as our main function, so we can actually have this. Okay, delta V out is equal to delta Q over C, and we know that this charge can also be computed by calculating the area of this inside this waveform. So this area is a square wave. Okay, so we have the width, which is the height is a V out over R multiplied with the width. So right now the width is actually dt because this is during t on. Okay, so we have d multiplied with t, or we can also write down V out d over R f. So we put this to the equation, delta V out is equal to V out d over R f multiplied with C. So right now we have already got the equation of the ripple output voltage. It has a unit, okay, volt. And as you can see, we can either increase or reduce the ripple, because for designing the DC-DC converter, the lowest the ripple is the best. Okay, so we can either increase the frequency or we increase the capacity. But usually we are more prefer to change the capacitor value, because this frequency we usually didn't adjust it because it's already will affect some other operation on inside the circuit. Okay, so this is the ripple voltage, and the other parameters that related is actually the ripple factor. Okay, so ripple factor R. So this one is actually a ratio between the ripple voltage over your output voltage. So this one can be equal to D over RFC, and this says no units. Okay, no unit because this is just a ratio. Okay, so that's all for the ripple output voltage. Thank you very much. We see you on our next lesson.